So please join me in giving a massive round of applause to our first speaker, Jan.
Hello, everyone. Great. It's great to be here. Yeah, hi, I'm Jan. I'm a co-founder at Zircuit. And oh, these are very, very bright lights today. Very excited to be here. I'm going to tell you a little bit about what we do. And I think it'll be a good, actually, primer for a lot of the other talks we talked about, or we were just introduced to. I'm going to talk to you about a rollup and some things related to rollups. And that'll set the stage for some of the nice technical talks later, or non-technical talks later, which is also pretty cool. So let's get into it. I'm going to try to tell you a story about how Zircuit came to be and what we're trying to solve. And in particular, how we're going to do this using AI. Because AI is a nice, trendy buzzword, but actually it's useful, and we can do some really cool stuff with it. So what's the problem? The problem is simple. Smart contract exploits are not a thing of the past. If you go here and talk to people, you probably will, on every other conference or every conference, hear about, man, did you hear about protocol X? They got hacked. Or, oh my God, people lost money. Or that protocol is insecure. Or some blockchain doesn't know what a second is. Or whatever. There's exploits and bugs all over the space. And this is really concerning. It degrades trust in this ecosystem. It sort of causes people to lose funds. That's obvious and not good. But it's not something we should be proud of as an industry, right? And there's been a lot of good people trying to solve this problem. Things like auditors or formal methods or just better coding practices help quite a bit, but they can't solve everything. And over time, though the sort of impact of each particular hack has gone down, the number of hacks has actually increased. This is almost to be expected. As you get more people into the space, you get more developers who don't know what they're doing, and you get more popular apps, and you get more ways to attract attackers. So hacks keep happening, and hacks probably will continue to happen. You can see the graph here. Actually, there's significantly more in 2024 than when the ecosystem started in 2019. That's sort of a good problem to have in the sense that means we've grown as a space, but it's not much better beyond that simple fact, right? Other than the fact that now we have more things to attack, we don't want hacks. No one wants hacks except for the hacker, and I bet even some of them don't even sort of really want it. They just wanted to see if they could, so they did. Because a lot of times they get sort of screwed with taking their money out anyways. But the point is hacks are still around. There it is. So hacks are still around, and they're not a thing of the past. And it causes all these issues that I've already talked about, right? We see that confidence goes down in the ecosystem, funds are lost, users get upset, people say, where's my NFTs, where's my my DeFi yields, where's my ETH, whatever it is, people get truly upset. And when you're trying to bank the unbanked, for example, and you say, well, put it into a DeFi protocol, but oh, oops, maybe you'll lose some funds because the developers didn't know what they were doing, or there was a new hack invented, or discovered, or whatever it is. This is not good, right? So we're trying to solve this problem, and generally speaking, hacks are still not welcome, right? Other than the research aspect of it, no one really enjoys these hacks, and it's actually pretty clear in the rollup-centric ecosystem that we've started to actually build out in the last 2 or 3 years. Here we've got a couple screenshots of people actually calling for resolutions to hacks that have happened, high-profile hacks, on some high-profile chains. And I'm not trying to call out these chains to say what they did or didn't do is good or bad, but just that this happened. We've seen protocols get attacked on Blast, on Scroll, and Linnea, and probably others that may or may not have been well publicized. I can't fit everything on a slide anyways. And people in the community say, you guys are not Ethereum, help us, right? You can control something in this space when you're a layer 2. And it's a very interesting idea to think about, well, yeah, actually, that's true. They are a layer 2. They're not bound to the same rules as Ethereum is, right? They don't need to do a hard fork like the DAO hack. They might need to do a smaller hard fork on their own particular network, but not necessarily convince everyone all over the world that what they're doing is going to be problematic or good. They just need to convince their user base that what they're doing is worth doing. And so, this is maybe controversial, but also maybe useful, right? If you're one of these people who lost $62 million on a game on a blockchain, you probably want that money back, and I don't blame you for that. I don't think anyone blames you for that. So can we do something about this? I think the answer is yes, and I think we should try to do something about this, right? That's the goal. The goal is to not have these tweets come up at all. What I don't want to hear is that, oh, there's a hack at a conference. What I want to hear is, oh, there could have been a hack, but someone protected the protocol or detected it or prevented it in other ways, or just never again, right? I kind of want the security industry in this space to sort of just get hidden away into the back corners so that we don't have to talk about these hacks because they're not fun, they're not sexy, and they're not helpful. So how can we do this? Well, first, we can learn from the past. All of these hacks that I've talked about, they're identifiable easily after the fact because people lose their money. That's pretty straightforward. But actually, you can do better than that. You can actually find these transactions in the mempool, and you can say, oh my God, something's coming. Or you can look at patterns, or you can figure out what it means to be a hack. And actually doing that precisely, maybe not so easy. So coming up with a formal definition that you put in a paper somewhere, maybe that's hard. But if I tell you, on the previous slide, someone lost $62 million, you're not going to say, oh, that wasn't a hack. I mean, you might say code is law, and so it wasn't a hack, so it's fine. But most of the time, most people will say, actually, that's not good. Let's do something better. So I posit that actually they are identifiable, certainly after the fact, and certainly we can come to a consensus on at least what most of them look like, right? Maybe we don't agree on every particular hack, but I would bet most of us in this room are really, in agreement about what the biggest ones are, or what the most problematic ones are. And so if we can identify these transactions, maybe we can do something about them. And so as I've said, they're sort of hard to define. Maybe they all come from different addresses, or there's no pattern there, but maybe they take ERC20 tokens, maybe they steal a different token, maybe they do something else. But they all do something, right? They do something that's unexpected, and that's sort of the key thing that we want to look at. And they're actually reasonably easy to detect, even in the mempool, or by running a node, or even on-chain as they occur. The problem is on Ethereum, you can't stop them, right? At best, you can front-run them to protect your own network, or to withdraw your own funds if you have funds in a protocol that's about to be hacked, but that's it. So unless you have a lot of capital lying around where you can front-run this right away, you're kind of screwed, right? You're at the will of the hacker at that point, and that's really hard to deal with. And the alternative is the hard fork, but you can't do that either. So that's really, really difficult. So, can we do other things? Because the goal here is to prevent them outright, and an ounce of prevention is worth a pound of cure, which means we don't want to have these conversations about how do we recover funds. We want to prevent these funds from being lost in the first place. And so through research, we can figure out that actually there's some patterns, and we can do some things. And one thing that's really, really good at detecting what a hack is, even if it's not me, is this thing called an AI, right? So AI is a buzzword, but it's a useful buzzword, and it's a useful technology. And you can train models to look at the previous hacks in Ethereum, right? Ethereum has been around for 5 years. There's a number of chains that look and feel exactly like Ethereum or slightly different. And so the hacks on those chains also look like hacks that they would be on Ethereum. And so you can train it on all of this stuff. You can say, look at the stuff that people lost money on, and if you see that happen again, tell me about it, right? And we can do something with that information, right? We can figure out what those patterns look like. We can figure out what it means to have a hack, and maybe we can come to a definition that's workable, if not perfect. And we can try to, tell people in advance. And actually, there are companies and services that do this. If you follow some companies on Twitter, they'll say, oh my God, there's a hack in the mempool in this protocol. Hey guys, can you pause? Generally, they first back channel through Telegram, but if they don't get a response, maybe they do it there. And if not, they're very proud of saying after the fact that they did detect in the mempool prior to the execution, even if they weren't able to get a hold of the protocol to stop them. But people have gotten really good at this. There's a lot of research working in this field that says, look, there's a hack coming. Let's stop it. The problem is on Ethereum, you can't do anything about it, because unless you're that protocol, unless you front run that hack, you're screwed. And if an attacker uses a private mempool, you're out of luck. So there's a lot of challenges there. But still, this is something worth looking into, because actually detecting a hack, detecting that a transaction as a hack, is a very sort of well-defined, easy problem. Unlike proving that smart contracts are perfectly secure, which is very difficult because you don't know all the execution traces and you don't know what the compiler might do, or a bunch of other reasons where you have to prove that something is perfect, detecting if a transaction is a hack is really just, is this one going to do damage, right? Not is any of them going to do damage, not is there ever a transaction that will do some damage, but is the one that I'm looking at right now going to be good or bad? Will people really like it or not like it? And that's really performant, helpful, and something that you can leverage in other ways, right? So people do it on Twitter, but maybe we can do it somewhere else, and that's where we're getting to. I'll talk to you about Zircuit in a bit. But in the end, some statistics, which I didn't cite here, but some models do actually do this very, very well. So they can detect false positives, or detect malicious transactions with a false positive rate of less than 0.01%, which means most transactions that they say are hacks are actually hacks. They're not someone who was doing something honest and then got miscategorized as something that's malicious. And they detect most hacks most of the time, and their false negative rate is quite low, which means that if there's a hack, most of the time they'll also catch it, which is really, really good. So this is not just hypothetical, and this is not a technical talk, so I can't go into how the AIs are built or how it's trained or all of that. But trust me or talk to me after the fact and ask me questions about it, and you can be convinced that AIs have gotten really good at this. And that brings us to an interesting idea of how to use this information. Because now we have a problem that I think we all agree is a problem. Malicious transactions are bad. And we have a tool that's actually quite effective at solving the problem if only we had a little bit of control. Right? If we had a little bit of control to say, oh, there's a hack in the mempool, don't allow it, then we can apply this AI to actually do something with that malicious transaction. And that's where we're going to go with Zircuit. Because rollups have different rules. So on the next slide, I'll introduce the rollup-centric roadmap a little bit. And essentially, rollups are these blockchains and blockchains, if you're new to the space, that more or less these days try to mimic Ethereum, not strictly so. Some of them do some special things with different opcodes or different features. And I'm going to talk to you about Zircuit, which has its own feature. But rollups can change the game. When you operate on a layer 2, you can integrate some of the tools that can be very helpful to you. In particular, you can do this AI thing, which I'll get to. Okay, so let me stop myself from going too fast into our solution, which I'm really excited about. So Ethereum has done a lot of really good things over the last couple of years. It's built out proof of stake. It's got some really good features being built under the hood, whether or not you agree with the FUD that's going on in crypto Twitter right now. But there's a lot of things it's done, and the biggest sort of push it's had in the last couple of years is to make rollups sort of the star of the scaling solution, right? Ethereum sort of said, oh, it's really difficult to get a lot of transactions on chain securely, so let's outsource some of that work to things called rollups, which look like Ethereum or feel like Ethereum or at least interact with Ethereum. And we can just have everything settle on Ethereum. And for your own needs of an execution engine, you'll take a rollup that's cheaper, faster, or does something more that you value. And there might be a couple of them, might be hundreds of them. Right now there's like 73 in production or something like this, so there's a lot right now, probably more than we need. But there's a lot. There'll probably be 73 more by the end of next year, or could be anyways, right? People will talk about app chains later, and those are their own special types and things like this. But essentially, this is really cool because now you can get a whole bunch of sharded execution layers that do different things. And scaling is very important, so getting cheap transactions, getting fast transactions is critical. We absolutely need that to get adoption. There's no way we're going to settle for 15-minute delays on transactions to pay for things. It's not going to happen. But 15 seconds might be okay, or something else. Totally fine. But when you start looking at these multiple rollups that are trying to solve essentially the same problem, you realize that there's no room for 73 exact clones. Or at least you don't really probably want that, right? There's going to be problems with liquidity fragmentation, which people have solutions for, maybe, but there's going to be just a question of why do I need 73 of the same thing? And people will start to differentiate themselves in different ways on these rollups. And one of the ways you can do that is to change the VM, right? You can say, I'm not dealing with the Ethereum virtual machine, I'm going to deal with my own. But you can also do other things, like change the rules of your block building, and that's what we do at Zircuit. At Zircuit, what we wanted to do was take that AI solution and put it into our sequencer. So what we can do is focus on scaling, just like any other zero-knowledge rollup. We could say we want fast, quick, cheap transactions. We're working on that. We also get security in the sense of like block building is accurate and all of that through Ethereum and the EVM and things like this. But we also wanted user security, right? So something that Ethereum doesn't talk about is when they say security for the Ethereum protocol, it means that you can't get bad transactions on chain in the sense that it was not valid, it wasn't signed, or you didn't pay for it. But the content of those transactions is totally free for all. And actually, that's a good thing. We want that on a layer 1. But there are people in the world who don't necessarily want that, right? If you had a rollup that you were going to talk to a bank about, and they said, oh, but you're going to allow a transaction that's going to steal my funds, maybe I'm just never going to go on your rollup because that risk is too high. My shareholders will not be happy with that. And if we want to widen the ecosystem or bring more users into the space, we need to at least partially talk to those people and see what their needs are, or others, or there's not only just banks we care about, and I'm not saying the goal of Zircuit is to bring banks on chain, but there are different actors in the world who want to use rollups or Ethereum or Web3 in general and are scared because they have these potentials for malicious transactions happening. And so what we wanted to do is say, well, can we do something about this? And that's exactly what we did. We took this AI. We took an AI that's very performant and very good at looking at malicious transactions, and we shoved it into our sequencer. So what that means is the thing that we have building blocks is going to look at transactions, and if they're bad transactions, they're going to wipe out someone's funds, we're going to put them in quarantine. And so users on the network can now be more rest assured, not perfectly 100% guaranteed, but they can have this extra layer of security that if they put funds into a DeFi protocol on our chain, well, there's no high chance of a hack going through that's going to take those funds away from them. And they get this for free. They don't have to do extra work. They don't have to use specific wallets. They don't have to do anything on their config side. It's just if they use the network, everyone on the network gets a little bit of security on this. Similarly, DApp developers, although they should be getting audits and although they should definitely write good code, if they happen to miss a step somewhere in that process or a new hack is discovered, they can rest assured that actually there's a really high chance that we're going to catch any transactions that will wipe out their funds. And so I think this is really exciting because now what this means is you have a network that provides some extra level of security. And so if you have risk-averse players in the field, they can jump onto our network. And then once they're on the network and they really feel like Web3 is the place for them, if they care about other things, about other features, other rollup techniques, they can always go somewhere else. But they're on the ecosystem, and I think that's what's really, really important. And what's also important is we do this without additional cost, and there's minimal performance overhead. The AI is actually really performant, so we don't actually have to worry about really long finality times or anything like this. So this is what we're doing, and we think it's really cool. We think there's a really strong use case for this, and we think it's generally a good thing. It may not be for everyone, but for those who are interested, we provide a safe space. We call this sequencer level security. And so just to recap the sort of technical-ish parts of it, generally speaking, in a rollup or in any blockchain, the blockchain will check that no one's created fraudulent transactions. Everyone's paid, everyone's signed transactions, and blocks are built according to some well-defined rules. There's a timestamp and there's a nonce. All of that should stay. But what we do in addition to that is make sure that actually the content of that transaction is actually not one that would be making news on Twitter for all the wrong reasons, right? What we don't want is transactions that allow us to steal, or allow anyone to steal funds from Aave or Uniswap or anything else, right? I'm not naming names for any particular reason, just like we don't want any malicious transactions. And I think that's really cool. And we call this sequencer level security. And how it works is sort of like this. This is my last slide. Essentially, we have a standard rollup architecture, so everything works out of the box. We're built on the OP stack, and we did some stuff. So all the network config works. It's very easy. Your wallet works out of the box, and if you're an end user and an honest end user, nothing feels different. You have a cheap, fast, zero-knowledge rollup. And on our end, on the back end, what we do is when we go to build blocks, we say, hey, when we include a transaction, is this going to be a malicious transaction given the current state of the chain? Right? I don't need to prove that every rollup smart contract is secure. What I just need to do is figure out, do I have a hack on my network? And if I do, I'm going to put it into quarantine. And if you're an honest actor, you can get released. It's all good. But if you're a dishonest actor or you're a malicious actor, it can stay there for a while. And I think people are going to be more or less OK with that. And what this will mean is that we won't have calls on Twitter for revert our chain, because we just won't have that hack. With high probability. I guess there's slight chance there, that epsilon of false negatives or false positives. But more or less, we will just negate the problem altogether. And we think that's going to be a really interesting user experience, a really good one. And because of the way the rest of it is designed, if you're honest and you're not trying to steal funds, everything just works. And it feels like a fast and good roll-up. So everything is kind of nice there. So with that, thank you. If you're excited to learn more about this, or you just want to talk to me because you don't like the idea, or something else entirely, come find me after the chat. I think it's important that we do look at things that can help bring people on board, even if they take sort of non-conventional approaches. And we're happy to try that, and we think there'll be a positive impact for doing this. So I think it's going to be very interesting to have this work, and try it out for yourself. Try Zircuit. Thanks.